Hey guys, welcome to the OneClass channel. My name's Sydney and I'm currently a third year engineering student at university. Today we'll be going over some commonly asked math questions at both the high school and university level. If you need some additional homework help or tutoring, please check out the links in the description below. And let's get started. Okay, so as you can see here, our first question is asking, how do you graph and label the vertex and axis of symmetry of y equals to 1/2 x squared plus 4x plus 10. I'll just write that out here. 4 equals 1/2 x squared plus 4x plus 10. Okay. So in order to find the vertex and axis of symmetry, I'll just label what vertex and axis of symmetry are. So first of all, the vertex is the local max or minima of the curve. So say we have a curve like this. This point at the bottom here would be the local minima, and the point at the top as the local maxima. Those are both the vertex of the curve. And then axis of symmetry. This represents it kind of like a line along. So this axis would be along the x value of the vertex. So once again, I'll just draw this really quickly. If we had a curve like this, and this is the vertex at the top, this line down the middle here, along the x value, I guess I should say not along, but vertical to the x value, perpendicular to the x-axis. That is the axis of symmetry. So as you can see, the curve will reflect the same image on both sides of the axis. Okay, so in order to find this information from this equation, what we're going to do is change the equation from standard form to vertex form. Okay, and how we're going to do that, I'm just going to write down an example of what the standard form is, and the vertex form is first. So the standard form looks like this, and the vertex form looks like this, h squared plus k. Okay, and how you would read this typically is, I like to read it like this. So the h here represents the x value of the vertex, and this y, or this k value, sorry, is representing the y value of the vertex. And I'm just drawing the arrows there as a reminder cue to know which one is the x value of the vertex and which one is the y value. That's how I remember, at least. And the vertex has the point hk. Okay, so that's what the h and the k tell you, and the vertex form of the equation. So what we're going to do in order to change our original equation into the vertex form, so we're going to complete the square. All right, so let's write down the given equation again. Plus 4x plus 10. And like I said, we're going to complete the square. Okay, So first I'm going to start by taking out the 1/2 from the first two terms. So removing 1/2 from 4 is the same thing as 4 divided by 1/2, or 1/2, or divided by is the same as multiplying by the reciprocal, so that's the same as saying 4 times 2, and that would give you 8x. So that's when you factor out the 1/2 from this bracket that we're creating, and then just leave the 10 term outside of the bracket. So now that we have this term in the bracket, what we're going to do is complete the square. So completing the square involves, let me just rewrite the beginning here, x squared plus 8x, involves adding this value here, 8 divided by 2 squared. So that happens, so you can also imagine this as b over a divided by 2 squared is this value that you're adding, okay? Remember we divided a, so this is a, this is b, and this is c. We divided b, which is 4, divided by a, which is 1/2. We did that originally to get 8. So that's why it's just 8 divided by 2 squared. Leave the 10 on the outside, and because we're adding 8 divided by 2 squared, how about I'll write it like this, we also have to subtract it, just so that we have a net 0 addition to this equation. We have to make sure that we don't, because this is an equation, remember, with two sides. So whatever you add to one side, you have to add to the other. So this subtracting 8 divided by 2 squared is equivalent to adding it to both sides, right? Add it to both sides, and you can move it over and subtract it from this side. All right, so plus 10, and what we're going to do is remove it from the bracket here, and when we're removing it from the bracket, as I drew the arrow showing the motion where we're putting it, we have to make sure to account for, oops, sorry, my pen's not working, account for this 1/2 out in front. So as we remove it, right, we have to, instead of divide by 1/2 when we took the 1/2 out of the bracket, we have to multiply by 1/2. Okay, let's write this. So 1/2 times x squared plus 8x plus, leaving this one inside the bracket, and removing the second term that we've added here, and putting that outside the bracket. So we have plus 10 minus 8 divided by 2 squared times, now remember I said times 1/2 because we're taking it out of the bracket. Okay, now we can simplify a little bit. 1/2 x squared plus 8. So 8 divided by 2 is 4, squared is 16, right? Plus 10, and we get the same thing. So this is 16 divided by, times 1/2. So basically you have this now. So minus 16 times 1/2, so half of 16 is 8, right? Okay, so now that we're here, obviously we can add these two together. And what we have to do here, there's a little trick that I use to think of how to turn this into, so basically, oops, basically what we want. This bracket here is a perfect square factor. So what I do to sort of think of what to put here is it's usually, or it is always, I guess, this middle term, so the b term, divided by 2. So 8 divided by 2, or simply just 4, right? So in order to confirm that x plus 4 all squared is equal to this term here, you can always multiply it out. And once you start to find the pattern of how a perfect square works, then you can probably remember that pretty easily. Okay, so plus 10 minus 8 is plus 2. And then here we go. Now we have the equation in vector form. So remember, I'll just rewrite what the vector form looks like. We have y equals to ax minus h squared plus k. So we know that looks the same, right? So we can find that h is equal to minus 4, since this in the vector form equation it's minus h, so in order to get plus we need a minus 4 term, and we see that k is equal to 2, and remember that the vertex has the points of hk, and so our vertex has the points minus 4, 2. Okay? There is one more way that you can do it without completing the square. I'm just going to move over here. So our second method shows that you can get h simply by using this formula, minus b divided by 2a. So if you look at our equation here, b is 4 and a is 1/2. So minus 4, 2 times 1/2. So that's minus 4 since these 2's cancel out. And k is usually found by subbing h into the original function. So remember our function from before right here, we have 1/2 x squared. I'll just write it out. X squared plus 4x plus 10. So if we're subbing h for x, and we found out that h is minus 4, we get this, so 1/2 minus 4 squared plus 4 times minus 4 plus 10. So minus 4 squared is 16. Oops. Minus 16 again here, plus 10, or sorry, I think I might have said minus 16, not sure, but remember squared just gets rid of the negative sign. And then, so that's 8, so that's 16 divided by 2, the first term. 8 minus 16 plus 10, and that will give you a final answer of 2. So, all in all, using the second method, we also get that the vertex has the points minus 4, 2. So I just wanted to show you those two different methods so that it's clear. You can use either one. And so now we have our vertex. So I'm just going to do a rough sketch of the graph. Right, so we have the y-axis and the x-axis. Rough, I don't know if that's enough actually. Let me take a look. I think I have a drawing of this somewhere. Okay, let's look at this one. Oh, I don't think I need to do anything specific with this one. We just have, so we have -4. Sorry, I was thinking of a different question. Here we go. So -4, 2, 3, 4. The vertex would be around here if this is 2. We draw that. -1, oops, 1, -2, -3, -4. So we know that our vertex is at -4, 2. And if we have our curve that looks like this, roughly, then we know that our axis of symmetry is down here, okay? Perpendicular to the x-axis. And so, as I said before, the axis of symmetry is found along the x value of the vertex. We know the x value of the vertex is -4. So the axis of symmetry is found along x is equal to -4. Okay? That should be that for that question. And it looks good. Good work. Solution. Because as we saw here, they also get -4, 2 using the second method that we used. So using the equation for h and k. All right, we can move on to the next question. Okay, our second question 2 asks how to write in point-slope form the equation of a line through each pair of points. So the first set is 0, 1, and the second set is 3, 0. So I'll just write that 0, 1, and 3, 0. So this is x1, y1 for our first set, and the second set is x2, y2, just for future reference. So it's asking for point-slope form, and so point-slope form is written like this. We have y minus y1 is equal to m times x minus x1. Sometimes you can see these subscripts written as I for initial. So instead of y1, it's yi or xi. So it just means the same thing. That's just the first point. And we can also find m from this equation with the equation y2 minus y1 over x2 minus x1. Okay? So that's what we're going to do. We're going to sub in the given points, and we're going to find this equation, the point-slope form equation. Okay? So, we'll start with finding what m is, since we'll need that. So y2 is 0 minus y1 is 1 divided by x2, which is 3, minus x1, which is 0. So we just get minus 1 over 3. And now we can sub it into the point-slope form. So we have y minus y1. Oops. y1 is 1. And just remember taking from this first set of points for the y1 and x1 is equal 2m, which we just found to be minus 1 over 3, times x minus x1, which we see is 0. So minus 0, or just, y minus 1 is equal to minus 1 over 3 times x. Okay? You'll probably rearrange the equation if you want to have it in a different form, but it's specifically asking for point slope form. So this is the equation of the line. If instead you wanted to find this equation using this set of points as your x1 and y1, you will be able to get the same result. Possibly just rearranged a little bit differently, but it will be the same result. Okay, let's look through here. We get the same slope, and they've also tried doing the same thing but with a different point. And as you can see, if you were to distribute that 1 over 3 minus 1 over 3 into this bracket, you will get the same result. So yeah, it should work no matter which point you use. All right, correct. Good work. And we can go on to the next question. For question number 3, it asks, what is the equation of the perpendicular bisector given by the points 1, 4, and 5 minus 2? Okay, so perpendicular bisector, let's write the definition for that. Perpendicular bisector. Oops. Sector. So that's a line that crosses the middle of the given line at a 90-degree angle. So crosses, same as saying bisecting. A 90-degree angle is equivalent to saying perpendicular, right? So that's what perpendicular bisector is. So when we're given, let's try plotting this so that we can visualize it. Okay. So we have y and x. So we need 4. We need 4. 1, 2, 3, 4. Minus 1 and minus 2. 1, 2, 3, 4, 5. 5. Okay, so as given in the question, we have points 1, 4, and 5 minus 2. So remember, this is x and this is y. So we have x is equal to 1 and 4. Y, that's equal to 4. So that's this point here. Y 4, 1, 4. And then the second point is x is equal to 5 and y is equal to negative 2. That's down here, minus 2. So imagine that I could draw a straight line between these two, right? The line that we're looking for, the perpendicular bisector, will cross this line, right in the middle, so equally spaced between this point and this point, and it will cross it at a 90-degree angle. I think you get the idea here in my box. So that's a 90-degree angle. So now we just need to figure out what is the equation of this line, right? Okay, so in order to find the equation of this line, we have to find first the slope. So the slope of a perpendicular bisector is always the slope of perpendicular bisector. We're going to call that MP. Is always the negative reciprocal of the given line slope, to be specific. The given line slope. So that means we have to find out what the slope of the given line is. Remember, we have the two points that are given here. Okay, so let's find the slope of the given line. That's, remember, the equation for slope is m is equal to y2 minus y1 over x2 minus x1. This is x1, y1, and this is x2, y2. Of course, you can do it as this as x2 and y2, and this is x1 and y1. It's up to you which you use first. So yeah, y2 is minus 2 minus y1, which is 4, divided by x2, which is 5, minus x1, which is 1. Okay, so from this you get the answer of minus 6 over 4, or if you simplify, minus 3 over 2. Okay, so remember it says here for MP, or the slope of the perpendicular bisector, what we want is the negative reciprocal. So negative, we know what that means. Reciprocal is flipped. So the negative reciprocal of the given line slope, which we just found out up here, right? So that is negative 1 over m, and m is negative 3 over 2, okay? So we have two negative signs here. We have this one and this one, which just cancel out. And then we are flipping the 2 up to the top, to the numerator, and that is the reciprocal, right? You can also think of it as 1 divided by 3 over 2, and remember you, what's the word? In order to, yeah, so if you're dividing, you multiply by the reciprocal. So yeah, that gives you the same answer. All right. So now we have the slope of the perpendicular bisector. So in order to find the equation of the line, the only thing we need left is a point along this line. So since they share one point right here in the middle, because remember it bisects right in the middle of the given line, all we have to do is find the midpoint between this point and this point, the two given points. Okay, let's do that. So hold on a second, oops. Midpoint, we are going to take the average of the midpoint of both the x points, so x plus x2 divided by 2, and both of the y points. All right, so this represents the midpoint of the x values, midpoint of the y values, or just the average of the x values and the average of the y values. And that will give you this point right in the middle that both lines share. All right. I'm just going to write as a reminder we have the points actually given here in the question, so I don't need to write them out again. All right. Let's sub them in. So x1 is 1 plus x2 is 5 divided by 2. Y1 is 4 plus negative 2. Okay, let's just simplify. We have 6 over 2 and 2 over 2, where that just gives 3, 1. And that is our point, or so our midpoint is 3, 1. So that's the value of this point here. Okay, so now for this equation, for the equation of the bisector, the perpendicular bisector, we have both the midpoint and the slope up here, and the midpoint. So in order to sub this into the point-slope formula, for the equation of a line, we know that y minus y1 is equal to m times x minus x1. So we can sub in y1, which is this. Remember, y1 is 1. Sub in m, found up above, which is 2 over 3 times x minus x1, which found to be 3. And there we go. If you want to rearrange this equation into a different form, we can write it in standard form or slope-intercept form, but that should be good for what it's asking, since it's asking for just an equation of the line. All right, so yep, that's the equation of the perpendicular bisector. Yeah, so this solution here also gives it in general form. So if you were just to distribute that slope of 2 over 3 into the bracket, you should be able to get the same form. Yeah, I think we're good for that. Let's say correct. Oops. Good work. And we're ready to move on to the next question. All right. This question is asking, what is amplitude? So this could be applied in a ton of different scenarios. So we could have this applied to physics or math, like a sine function or a sound wave or anything like that, since they typically oscillate. If we're looking at a wave, let's imagine this is time, and we have a sine wave here. Oops, trying my best to draw something quite, I don't know, a little bit even. We can see that it oscillates with time, right? So there are a couple of things that we can label about this graph. First of all, we can label this distance here. So the distance from the beginning of one cycle of a wave to the end of the cycle, that is the wavelength. And what this question is asking for, actually, oops, not quite top, but it's not a perfect wave. This distance from the, if this was x, for example, from x equals to 0 to the maxima on the wave, that would be called the amplitude. Amplitude. Oops. That's how you spell it. So, let me just read the explanation here. Amplitude is the highest point or the maximum displacement of points on a wave. It can also be considered the intensity or degree of change of a wave. Another thing that's measured from the wave is the wavelength, which I have labeled here. And that is the distance between two successive points, like adjacent peaks or troughs. So this, from this trough here to this trough here, this is also considered the wavelength, right? So this should be, sorry about that, this should be the same distance. I mean, my graph isn't perfect, but roughly the same distance, right? So yeah, the distance between two troughs, which are the minima, or the distance between two maxima, should be the same as the distance between this point at where x is equal to 0 to this point. After, like I said, one full, yeah, it says here wavelength is also considered for the time, or consider the time for a wavelength to complete a full cycle. All right, let's keep reading. The amplitude is measured from the equilibrium position, right here, where x is equal to 0. It's seen as the shape of the medium when there is no disturbance from a wave, hence it is at constant. Another way to think about the amplitude is that is the vertical distance from the equilibrium to the peak or trough of a wave. So yeah, since this here is the amplitude, I keep drawing over the same lines, but this is the amplitude. This distance here is also the amplitude. So from the max to x is equal to 0, or from x is equal to 0 to the minima. So these should be the same amplitude for both of these things that I've drawn here should be the same value. I just obviously don't have a perfect drawing, but yep. So the amplitude is the vertical distance, and the wavelength is the horizontal distance. It also talks here about frequency. So it says that frequency is the number of oscillations or wave cycles per unit of time. It's not really exactly like asking for that in this question since we're just talking about amplitude. So I think I'll leave it there. If you want, you can pause the video and read that description as well if you're interested. I'll just say correct solution. Good job. And we can move on to the next question. All right, so our fifth question, back to black. Fifth question asks us, expand using the rules of logarithms, then differentiate. Asking us specifically about y is equal to ln 7x divided by 2x minus 3. What's following this question? I'm not sure we'll need. Probably see it come up somewhere in the solution as we go along. Okay, so the first thing that we can do here is separate the log function. Sorry, the ln function, it's not a log. And for that, we can use the ln rule, or the ln law, quotient ln law specifically. I have to remember how to spell that. Quotient ln law. And that states that the ln of x divided by y is equal to ln x minus ln y. Okay, so let's see how we can apply that to our equation. So we have y equals to, well, I don't need to write it again since I have it right here. But yeah, we have two values divided by each other. So if you imagine this as the x here, and imagine this term as the y here, then we can write it easily like this: 7x minus ln of the denominator, which was 2x minus 3. All right? So now that we separated it, it will be a little bit easier to take the derivative. So that's what we're going to do now. Take the derivative. And so dy, oops, keep hitting things with my hand. Dy by dx is equal to d, or dx of this whole function here, ln of 7x minus ln of 2x minus 3. And since these two are being subtracted, you can separate this derivative into d by dx of ln 7x minus d by dx of ln 2x minus 3. Okay, I just separated it because they're just being subtracted, so they don't need to be considered as one full term. And this makes it a little bit easier to understand. So I'm going to separate this into two parts just because it might be a little bit clearer this way. Also, I'll show what the solution does here. The solution goes into a little bit more detail than I think is necessary. But you can try doing it this way if you'd like, just by letting, so what the solution does is we'll start with 1 here. So this first term, which is d by dx of ln 7x. And like I was saying, this solution lets u equal to 7x. So then what you're doing is taking the derivative of ln u, right? And that's pretty simple because it's already a known function, right? I'm going to leave that out so we can go through a little bit more quickly because I think it's fairly easy to understand. But if you need it, it'll be here on this left side. Okay, so the derivative of ln 7x is, well, we know the derivative of ln is 1 over x, but in this case we have 7x, so we'll put that in the denominator. And since we have 7x, we have to also take the derivative of what's inside the ln function. So the derivative of 7x is just 7. So since there's 7 and 7, they will cancel out, and you'll just get that that's equal to 1 over x. All right. So now we can move on to the second half here. That's what I have, or the second term, I should say. They also sub in v for 2x minus 3, but it's the same process as 1, so let's try that. 1, 2x minus 3. So that's just the second term from what we have above. Hopefully I'm not blocking it. And it's the same process, like I said. So the derivative of a ln function is just 1 over x, or in this case we have 2x minus 3, times what is the derivative of 2x minus 3. So 2x, derivative of that is 2, and the derivative of minus 3 is just 0. So it would be, oh,